Hi, this is Russ Andersson, and I'm going to demonstrate the stabilization features of SynthEyes. So I'll start by opening up our shot, and it's a 16:9 dV shot. And we're going to just start off by doing a quick auto track on it. And by doing this, the stabilization is going to be able to use the full 3D location of the points, which are a lot more accurate than any individual 2D frame feature. And it also has the field of view of the camera, which lets it do accurate stabilization and get the keystoning correction exactly correct. So you can see our solution is done, and we could do a 3D insert at this point, but instead we're going to bring up the image preprocessor, which is the home base for the stabilization features within SynthEyes, as well as the other features for the image preprocessor. What we're going to do is select a bunch of features in the center part of the image here and use them as the thing to be stabilized. And again, we're going to be using the 3D reprojected versions of those points for accuracy. And we'll just kind of nail them in place. And what happens is, as you go through the shot and you're maintaining the position of those things, it gets a little weird because the helicopter is actually orbiting around this point. So what we want to do is go to the end of the shot, and we're going to create a kind of countervailing rotation that'll correct for that. Maybe we'll just grab the bullseye here in the middle and just kind of recenter a little. This just is creating a little hand animated motion to offset and minimize what we need to do to the shot to maintain the stabilization. So at this point we could just close out of this panel, and right now it's going and recomputing the new versions of each of those frames, and now you see a stabilized version of the shot, and of course you have all these black parts around the edge, and you see also now that the trackers are still moving around madly. But what we'll do is now we're going to go back to this stabilized panel and auto scale, and what that's done is zoomed into the shot a bit and done so that there's never any black portion that extends past the edge of the source shot. Here I've just switched mode so that you can see this red rectangle here is the portion of the original source image that's used to produce the output. And that kind of goes exactly up to the edge at the minimum possible zoom factor. The zoom factor over here, 1.4, is actually a bit high. We'd really rather be running down in the 1.1, 1.2 sort of range, sort of like a 10 or 20% increase in the size of each pixel. If this gets up to a zoom factor of 2, basically you're losing about half the resolution of each pixel. So that's not a good thing. But at this point, we could again run back and see the zoomed version. And now we'll just flip off the trackers, the 3D points, and you see a nice little stabilized shot. And there are plenty of different ways to do this depending on the circumstances. We could in fact update the tracker positions to reflect what we've done to the shot as a result of the stabilization. Here you can see what field of view is calculated, and that's being used here. Could have compensated for distortion at this stage also as part of the stabilization process. Now, at this point, there's no reason that we actually need to output kind of the same kind of image as is coming in. So we could actually resample the output to a 4:3 image. And this is what you might have with a workflow where you've shot HD and you're going to produce a standard definition output. Or you might be taking some film resolution input and producing an HD output, which is pretty common. And this will let you resample to that new resolution. And in this case, the zooming factor may be, a fairly large zooming factor might be quite acceptable because you're not really, you don't really need that high of a resolution because you're oversampled to start with compared to what you're producing. So here in this particular case, though, when we auto scale, we're going to wind up needing even a larger zoom. But we can get that and see what our new 4:3 output would look like. And, it's all pretty simple and straightforward. At this point, we might go and just be ready to save it away, and we could just save it away to disk. And that would be great. Or we might go and use this footage to do some additional tracking in order to be able to do a particular 3D insert in some fashion. Or generate a mesh, whatever, a lot of different possibilities. That's the very quick outline of the whole thing. Hope you enjoyed it. I invite you to go download the demo and give it a try for yourself. Thanks.